Okay, so now I'm gonna address the promise I made in the previous video. I'll try to solve this problem. So given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. So the constant memory. So if I'm removing this requirement, how it's gonna work? If I see the node that repeats, I will just return it. Easy peasy. So I'll have this scene equals set, and then say I have a node equals head, and then if head is none, I'm gonna return none. Then while node is not none, I'm gonna do something, and then in the end I'm gonna return false, or like return none. And then here I'll check if node in scene, then I'm gonna return otherwise node scene add node, and then node equal node next, something like this. So this was of and memory, pretty the same solution as I did before, but for the turtle and the hare solution of one, I need to drastically upscale my game here. So as I said, we start with let's think about algorithm I wanna apply here. So I start with 3, and then I go to 2, and then I go to 0, and then I go to -4, and then I'm gonna go to 2 here, and then 3 here, and then I'm gonna go, so like I'm gonna start fast slow pointer. Fast goes 2 nodes, slow goes 1, fast goes 2 nodes, slow goes 1. Fast goes 2 nodes, slow goes 1. They match each other. And then if I gonna start one pointer from here and then continue going one node at a time, it's gonna be exactly the same. So let's say I start here, pointer here, pointer here. So I do one node at a time. I move the pointer to here, so this one becomes pointer, and then I move this here pointer also from here, so like pointer, and those pointers met, and where those pointer met, I should return this node as output. So how to prove that? So let's assume like we start with this one, and that the path is gonna be from here to here, gonna be A, and then the fast here gonna go, let's say 2B So the path for the fast here gonna be, let's say, a plus, let's say, some length c, and then let's say a plus c, and then the slope pointer gonna go a plus, let's say, k, and then they're gonna meet each other at some point. They're gonna meet each other at some point. So I need to somehow convert this one to the kind of circular relation. So if I go a plus c, so c mod, let's say we have path, say q, c mod q equal k mod q. So let's say every node here, let's say in a cycle has a ID. This one ID 1, this one ID 0, ID 1, ID 2. And then I need to somehow figure out, okay, what the C and K relationship, and I know that the total path that here came, it's or like ran is like 2, let's say 2p, and this one path is gonna be p. So this one is equal p, this one is equal to p, and then I have this equality. So how many variables I have here? I have 1, so 1, 2, 3, 4 variables, 3 equations. So if I have, okay, let's go. Here gonna be a plus c equals 2a plus 2k. Oh no, they are not equal. They are not equal to each other. Wait a second. Or equal. Yeah, I can just substitute this one to this one. A plus c equals 2a plus k. And then I have this condition, if I divide c and k mod k, q is gonna be equal let's assume they meet in the point, let's say S, and then yeah, it's kind of, I don't remember exactly how to prove that. Let me just code the solution, and then I'll come back to the proof if I'm gonna have some time. So this is OFN solution, so I wanna have of one space complexity solution. So we'll have the start gonna be the same, and then I'm gonna have fast equals head, and then slow equals head, and then while fast is not none, if fast is equal slow, I'm gonna go ptr equals none, and then I'm gonna go fast is equal ptr. And then here I wanna also break. And then here I'm gonna be fast equals fast dot next. And then if fast is not none, I'm gonna go again fast equals fast dot next. And then slow equals slow dot next. And then in the end, I want to check, I want to start over again while, let's say, ptr1 equals head, then ptr, let's call it ptr1, and then ptr2 gonna be just ptr, and then while ptr, this one only if ptr is not, if ptr is none, I'm gonna go return none. Otherwise, I'm gonna go this. I'm gonna reassign those ptrs, and then while ptr1 not equals ptr2, I'm gonna go ptr1 equals ptr1 dot next, ptr2 equals ptr2 dot next, and then return ptr, let's say 1. So let's check what's happening there. That one, no cycle. Or should it return optional list node? Okay. Tail connector node at 4. 3204. Pause equals interesting. Why it is not working? Head is none, return none. Fast equals head, slow equals head, and then ptr equals none. Then while fast is not none. I know. No, still no. Let's add some some marker. Doing binary search. Okay, so it's even have not landed here. Oh, okay, ptr equals fast. It was easy. During the node where the cycle begins. If there is no cycle, return null. Should I return ptr? Let's print again. Print 1. Okay, so let's print pointer. Print mod, then ptr dot wall. So value three. Why it is 3 here? ptr gonna be equal fast and then break. Let's go ptr wall. Three. Why it is 3? ptr. It should be 4. It should never go to the... Oh, I got it. So this check is too early. So I need to move first and then check. Yeah, that was interesting bug. Yeah, so now how I can prove this this gonna work? Let me check the time. Some time left, like around 2 minutes. Let me try to come up quickly with a solution, with a proof. So should I add this interim variable s and solve it like here? Well, it seems like I have two equations. The first one is this one. And the second is with this one. C mod q equals k mod q. So C gonna be 2a plus 2k. If I move a to this side, it's gonna be just a here and plus 2k. And if I do a plus 2k mod q, is equal k mod q. So that's the equation. How many variables? Let's say I know this one, and then I wanna go a plus, so this case meeting point so if can I move k to the other side of the equation? I don't know. Let's pretend I can. A mod kq equals let's add like q here plus, and then q here plus, and then I have a plus q mod q. That might be not necessary, and then here q. So I know that it's not necessary, but on this side q minus k mod q. So a mod q equals q minus k mod q. So if I start working, can I prove that if I start working from this point and from this point, they can eventually meet? I don't know. I'm gonna wrap it up because it's already too much time. So that's it.